Good morning. Good morning. Today I'm doing the last part of the Metro Central Education District Common Trial paper. This is the question paper that I'm going through from Western Cape. This is Geography Paper 1 preparatory paper, common paper, which was written on the 29th of August 2025. So I covered question 1, which is made up of climate and weather. So I'm on question 2 now. I'm on question 2. And on question 2, I've done question 2.1. I think if you can check on my TikTok, you can see I combined 2.1 and 2.2 together. So for today, I'm moving on to 2.3. So I'm going to do 2.3, 2.4, and 2.5 separately. Then I'll upload them separately as well. The reason why I'm doing this, I want to make sure that you've got information that is more comprehensive, information that is simplified and easy to understand. But sometimes when you try to mix concepts, then it becomes confusing. So that is the reason why I'm trying to tone it down a bit to make sure that I don't overload you with a lot of information. I explore a concept per video. I explore a concept per video. Basically, this is what will be covered by each and every person that I'm going to upload from now onwards. This will also help you to understand, to have a better comprehension of the concept that I'll be going through, and also trying to explain, trying to make them as simpler and easier as possible to you. This is the mission of this TikTok, is to develop the passion about the subject, is to help you have a better understanding that is simplified. I know sometimes as educators we make things difficult, but I've dedicated this TikTok just to make everything as simple as possible. There might be some, I can't say mistakes, but there might be somewhere where maybe the way I explain, maybe you don't get it right. Please don't hesitate to comment. I'm open to all criticism, be it negative or positive. I think this is what helps me to improve. If I make a mistake, maybe in terms of the way I've explained the concept, please don't don't worry. You just comment. You just put a comment, and I'll make sure that next time when I upload another video, I'll do it the right way. Okay, thank you so much. Let's go through 3.3 so that I don't waste time. Refer to the diagrams showing drainage patterns. Guys, I've emphasized, if you can still remember from my previous video on the Northwest Spring Camp, I think I covered this question 9.1, which had this drainage pattern, the rectangular and the dendritic. I also did a question which had the radial and the trellis. Just to remember, please go through these videos, and also this one that I'm going to upload now, because it's also covering drainage patterns. I think if you can watch these 3 videos, I don't think you'll have any problem in as far as the drainage patterns are concerned. Let's move on. All right. Refer to the diagram showing drainage patterns. Guys, the first thing now, when you look at these drainage patterns, what comes to your mind? What comes to your mind? Do you still remember? Some people, they confuse a trellis. Okay, this is a trellis. You can see the mainstream, they are parallel to each other, but the tributaries are joining at what? At right angles. They confuse a trellis with a rectangular. You can check your rectangular now. How does it look like? You can see the mainstream is bending at 90 degrees. The tributaries are also joining at 90 degrees. So this is the major difference. Of course, we can talk about the underlying rock and the rock structure and the other stuff. But you can see just by looking at here, you can just see that, okay, this is a mainstream, but at what angle is the other of the other streams joining the mainstream at? It is 90 degrees. Then if you look at this one as well, you can see, even before I go into attempt to answer the question, okay, it resembles the branches of a tree. The tributaries are joining the main, okay, at acute angles. So already you've got something that you know in as far as the two drainage patterns that are being assessed are concerned. So this is what we really need you to do. We want you to be prepared to such a point that even when you get hold of the question, In 2 minutes, you would have assessed everything, you would have gone through the diagrams and also get the answers for everything that you are going to do. I want you to check here as well at the bottom. Something that guys you would always check. This paper, of course, in order for us to avoid plagiarism, we acknowledge the source. Where did we get these drainage patterns from? So I want you to check something here. Adapted from https www.google.com, search G trellis. Yeah, guys, trellis and dendritic drainage pattern. So already the answer is here. You see the answer here. You have to be attentive to detail, guys. Everything that you are given in exam, it works. Everything that you are given in exam, it works. So you see, even before I start answering the question, the answer is there. You can see trellis and dendritic pattern, drainage pattern. So it's there. It's there. And they are going to ask you, identify the drainage patterns of river A and B. Come on guys. But the answer is here. And in the correct order. This is your trellis. This is your dendritic. It's in the correct order. So that's why I'm always saying, now, be attentive to detail. Don't ignore everything. Don't ignore anything that you see on a sketch. Don't ignore anything that you see on a diagram or in an infographic. It can help you to get the correct answer. Let's go through it now. Identify the drainage patterns A and B. The answer is already there. This is your trellis. This is your dendritic drainage pattern. It's already there. I showed you guys. This is the answer here. It's okay. Check here with the website where this one was adopted from. This is trellis and dendritic drainage patterns. Okay. Let's move on so that we don't waste time. Differentiate. Okay. Differentiate between the underlying rock structure of drainage A and B. So we are saying now where the drainage patterns are formed. The difference is how the reason why we have got the different shapes that we have is because of the rock structure and also the underlying rock, which is different. That's why even if you look at the shape that they assume in terms of the description, you see that is different. So the main influencing factor there is the underlying rock structure. That's what makes these drainage patterns to be different. Okay, so what do we have then? So we are saying for trellis, this is your trellis. What is happening is you find it on an alternating layers of hard and soft rock, or folded rock structure, or undulating rock structure, but I'll just stick to, let's say, folded rock structure and alternating layers of hard and soft rock. That's why you have it like this. Alternating layers of hard and soft rock. So you see now where it avoids, like this one obviously is made up of the hard rock, and where it erodes is also made up of the soft rock. That's basically what this is all about. So it's alternating hard and soft rock, just to simplify it. Okay, then for B now, which is your dendritic, what is the underlying rock structure of B? This is your B. Obviously, this is the rock that is uniformly resistant to erosion. The rock is uniformly resistant to erosion. That's the underlying rock structure in as far as the dendritic is concerned. So that's what we are saying. Let's move on to question 2.3.3. Why are the tributaries of the main stream parallel to each other in the drainage basin A? What are they parallel to each other? The tributaries, why are they parallel? They're joining the main river here at 90 degrees. Why are they parallel to each other? Why are they parallel to each other? What is the reason behind them being parallel to each other? Of course, this is now question 2.3.3. This is now question 2.3.3. In A, why are they parallel to each other? The streams flow in relation to the folds of the rock. They flow in relation to the folds, okay, of the rock. The streams flow over softer rock of the syncline, valley, or interflows are parallel. That's basically what it's all about. Of course, what is an interflow? It's a highline area that separates two rivers within the same river system. So that's basically what we are saying. So in between, that will be the interflow. Okay, it separates streams within a river system. That's an interflow. So we are saying interflows are parallel. The streams flow in relation to the folds of the rock, or the streams flow over soft rock of the syncline. That's basically what we are talking about. Let's move on to the next one. Determine the stream order at point 1 in the drainage pattern B. So we are talking now about the stream order at point 1. Let's do it together. I'll try to zoom in the camera so that you can see how I'm going to do it. So we are saying now, let's start from sketch, okay? This is 1, 1, which means we lead to stream order 2. Okay, 1, 1, we got 2. Then we have got 1, 1, we got 2. Okay, 2 plus 2, what do we get? We get 3 here. I follow you. 1, then here we have got 1, 1, what do we get? 2. Then we have got stream order 2 and 1, which means this one becomes 2. Then what do we have? 1, 1, we got 2. 1 here, here is 1. 1 and 2, we got 2. 2 and 1, we got what? 2. Are you following? Then here is 1, 1. What do we have? 2. 1 and 2, we got 2. 1, here we have got 1 and 1, we got 2 here. 2 and 1, we've got 2. 2 and 2, what do we have? We have got 3 here. Of course, we want to see what we have at point 1. So here, so what do we have? 2 and 2. Okay, 2 and 2. So it means at 1 we have got what? 3. That is the answer. I think you've seen how I've done it. Let me just take you through again. So what I've done in as far as stream order is concerned, 1 and 1, it gives me 2. Then 1 and 1, it gives me 2. 2 and 2, high order, 3. Okay, 1 and 1, 2. 2 and 1, we got 2. And you see? Then here, 1 and 1, we got 2. 1 and 2, we still have 2. Okay, 2 and 1, we still have 2. Okay, now this 2 and 2 now. You give us the highest order, which is now 3. That's how we got to order 3 at point 1. You see? Even if I go here, 1, 1, 2. 2, 1, 2. And you see? Here, 1, 1, 1, 2. 2 and 1, 2. Can you see? But the question now is asking what the order at point 1. So that's how I got the third order. That's how I got the third order. That's how you do it, guys. It's very easy. That's how I did it. Okay. Let's move on to the next question. 2.3.4. Choose the correct word between brackets to make the statement true, which means you are given these two options. You are supposed to choose the correct answer. That's what it means. The higher the stream order, okay, let's check here. The higher the stream order, of course, where we have got more streams, are we likely to have higher drainage density as well? That's basically what the question is all about. So we say that drainage density is the total length of streams per unit area, which means the more streams we have, it also means that the higher the drainage density. The more streams we have, it also means the higher the stream order. That's basically what we are talking about. If you can compare the stream order between the two, you can see that here the stream order is high because we have got a lot of streams that are flowing. We get a lot of streams that are flowing. If you can also compare here, you can see that there's a lot of streams that are flowing here as compared to there. There's a higher stream order. There's also higher drainage density. That's basically what I'm talking about. If you can also compare the two, you can see which one has got more streams flowing between the two. So that's basically what we are talking about. The higher the drainage density, the higher the stream order. That's basically what we are talking about. That's basically what we are talking about. So the correct answer, to go back to the question, choose the correct word from brackets to make the statement true. So the correct answer is higher. It's higher. The higher the stream order, the higher the drainage density. That's what this is all about. Refer to the drainage pattern B and describe the relationship between drainage density and low rainfall, drainage density and steep gradient. So what I want to emphasize here, guys, is when it comes to drainage density, all right, when it comes to drainage density, you need to know what is drainage density. That's the first thing you need to know, density, because you cannot explore a concept that you do not understand, that you do not comprehend. So what is drainage density? It's the total length of streams per unit area. So when it comes to drainage density, there are two processes that you should always compare: surface runoff and infiltration. So if you want to explore drainage density, these are the two concepts that you should compare. What do I mean by that? Which means where we have got more surface runoff, we are likely to have more streams flowing. Are we together? Where we have got more surface runoff, we are likely to have more streams flowing. And where we do not have surface runoff, there's bound to be more infiltration, which means less streams will be flowing. That's basically what I'm talking about. So these two processes are the ones that contribute to either high or low drainage density. So we are saying now the higher the surface runoff, if we have got more of surface runoff, which means we have got more streams flowing, then we are likely to have a higher drainage density. Where we have got less streams flowing, which means there is more infiltration that is taking place. Hence, we have got a low drainage density. That's basically what we are talking about. So let's look at what we are supposed to link the answer to. Refer to the drainage pattern B and describe the relationship. So the drainage pattern B is our dendritic. Okay, so let's explore now the question. So we are now saying now drainage density and low rainfall. If we have got low rainfall, it means we are going to have less streams flowing. There's going to be a few streams flowing because we have got low rainfall. Are we together? We are going to have less surface runoff. So which means, what does this encourage? It encourages a low drainage density. That's basically what we are saying. We have got a fewer streams flowing. That's basically what we are talking about. We have got a fewer streams flowing and there's less surface runoff. So basically we are going to have what we call a low drainage density. So that is the relationship between drainage density and low rainfall. We are likely to have less streams flowing, which can result in low drainage density. That's basically what we are saying. That is the relationship between drainage density and low rainfall, which means the less rainfall we receive, the less likelihood of us having surface runoff, which contributes to more streams flowing. So if we have got less surface runoff, which means we have got a fewer streams flowing, hence I'm talking about the low drainage density. Same applies when we look now at drainage density and steep gradient. We are now saying that a steeper gradient is like this, which means when it rains, water is not allowed to settle on this slope. It's not allowed to settle. As soon as it rains, we have got more surface runoff. As soon as it rains, we have got more surface runoff on the steep gradient. Why? Because water is not allowed to settle. The moment water does not settle on a slope, which means there is no infiltration taking place, there is more of what? Surface runoff, which means we are likely to have a higher drainage density. That's what it's all about. I'm going to do it again. So I've said that when you talk about drainage density, we are exploring two concepts, that is surface runoff and two processes, surface runoff and infiltration, where the surface encourage more surface runoff, or the conditions are conducive for more surface runoff, we have a higher drainage density, and where the conditions encourages more infiltration, we have got a lower drainage density. What do I mean? Like for example, where we have got low rainfall, which means if fewer streams are going to flow, therefore the drainage density is lower. That's what I'm trying to say. That is number one. Okay, think of a gentle slope. A gentle slope, what does it do? It allows the water to settle, which means that when the water settles, it starts to infiltrate. Then there's reduced surface runoff. Then it results in low drainage density. So low rainfall, less rainfall, less streams flowing, low drainage density. Low rainfall, less streams flowing, low drainage density. Low rainfall, less streams flowing, low drainage density. Where we have got a steeper slope, we are going to saying down, the steeper the slope now, it means we are likely to have more surface runoff because water is not allowed to settle. As soon as it rains, then it starts flowing, we have got more streams. That's how we have got what? A higher drainage density. So boys and girls, this takes us to the end of 2.3. I don't want to do it for a lot of time, to a lot of minutes, because I want to make sure that you are able to go through this question and also understand the concept in a similar way, especially the way that I've tried to explain it. I think it's very simple. Thank you so much. Have a blessed day.